work, we need to see how Pleurotus Ostreatus will work under natural conditions. That means competing with other organisms, dealing with different temperatures, weather patterns, humidity, all that kind of stuff. We need to make sure that it will still function. Then we also need to determine what the best way to implement this fungi would be in terms of, do we want it to be dead? Do we want it to be alive? Does it need to be whole? Do we want it to be in a powdered form? We already did address here that turning it into a powdered form will increase the surface area and then allow for more adsorption. The problem with that, though, is how do we get it out of the infected wetlands after that? That brings us to our lab work. Again, trying to examine what form would be best to use the fungi in, as well as determining what percentage at which Pleurotus Ostreatus picks up heavy metals. So you might have noticed in our results section, we did not include the initial heavy metal concentrations in the soil, and that was because it just wasn't provided by most studies. There's no percentage. We don't know how much biomass we would need. We don't know if the initial concentration matters all that much, although it's kind of suggested that it doesn't matter too much. And then finally, we need to figure out what will happen once the fungi starts to decompose. So let's say we took this mushroom, brought it into the ecosystem, picks up the heavy metals, and after it dies, what happens? If it starts to decompose, are the heavy metals released back into the wetlands? Do they still somehow stay concentrated? How long do we have until the fungi starts to decompose? All questions like that we still need to have answered.
Is there any indication? So you said that maybe you would try putting live or try growing Pleurotus Ostreatus in wild situations in constructed wetlands. So Pleurotus is primarily a sap probe, right? It decomposes wood and the like. In constructed wetlands and wetlands as a whole, would there be any indication of a higher decomposition rate for the entire ecosystem with the introduction of this fungus? And would that have a negative effect on the nitrogen cycle or other nutrient cycles?
It does determine what form we would have it in. If we decide to grow it out of the constructed wetland, it's possible that that could happen, but it's very unlikely that that's the route we're going to take. More than likely, the fungi is going to be dead when we're using it, so it's not going to be digesting anything. It's just going to be the cellular process of picking up the heavy metal ions. And again, if it does start to decompose, that could cause its own slew of issues, but most likely, even if we did decide to grow it out of the ground and the fungus was still alive when we were using it, we would use a strain that isn't able to reproduce, so hopefully we would minimize any type of impact like that.
And because they're natural to growing on trees and into a lot of these wetlands, it won't disrupt the cycle that much. It'll probably end up being in competition with other saprotropes, and will have minimal, if any, effects on the overall amount.
So you said you weren't going to use you're probably not going to use live fungus.
Yeah, most likely.
So the alternative would be using powdered mushrooms or powdered fungus?
Not necessarily. We could use it chopped up just normally. We could use it if it's chopped up and dried. There are a lot of different forms we have it in, and one of them would be powdered, but again, that does present the other challenge of how do we get it back out. But if that is an issue, we can still use it dead and chopped up, and it will still be effective.
In all of these cases, how do you propose to actually remove the metals from the environment? Because right now you're putting the fungus out there, absorbing all these, ions, but then I'd say that going in and picking up each individual oyster or each, powdered cell or chunk, I feel like that would be kind of a painstaking task.
So that is something that we did, that's something we're planning on doing next semester. However, we have talked about a couple of different ways to keep it contained. We talked about a couple of basket methods. Our research stream advisor also mentioned one way with a tubal system, so we could actually test it out. But we could test it out in the constructed wetland without having the risk of exposing the entire mushroom to the rest of the ecosystem. We'd also probably start off with a relatively small area of the constructed wetland to be able to figure out its effects and just how much of it we're going to need, which goes back to one part of our future works.
And why Pleurotus?
Well, Pleurotus, first of all, super common, not toxic to be eaten, so it won't introduce a new toxic food source if we actually introduce it live. And also, it is particularly good at absorbing pollutants. Like I said, it's capable of absorbing, breaking down plastics. It's a lot of mushrooms are capable of filtration, but Pleurotus has like a really strong ability, especially with heavy metals, more than a lot of other, and also to stay functional through the saturation point, like absorbing heavy metals, is a lot lower.
Yeah, so also have been other studies and studies that we looked at to actually determine what fungi to use. It has been shown to be more effective than pretty much any other fungi, including other types of Pleurotus fungi.
All right. So you mentioned, this whole thing about Pleurotus dissolving and metabolizing plastics. How realistic would that be to use in these situations? Because from what I remember, those are in like pretty highly controlled situations, aren't they?
Well, the thing is, plastics, it breaks down, lignocellulose, I think it was. It breaks down the more, not organic, but the bonds that are broken in plastic are not present in the metal, so it can't use it as a fuel source, which is what it does with plastic and how it gets rid of it by absorbing into its natural cycles. The metals aren't fully absorbed into the natural cycles, and it can't do anything with it, so that separates the situations.
Yeah.
I don't know if I misunderstood you, but I might
No, you
have.
got it.
I got really excited about the plastic thing.
Yeah, it's really interesting. And they can dissolve biofuels as well, like propane and stuff like that.
I said it to another group. Fungi are pollution with water is the problem.
It's all about manipulating the genome of specific individuals to allow the use of specific enzymes that are not currently used, which is just why it's maybe, I don't know how realistic it would be currently to use that in the wild, but it's definitely a possibility.
Yeah, especially because it is constructed that we're focusing on and not fully natural spaces. We're going to let our other group members take in right now. Your interest is up here.